Now let's make a new method. So there is a task 1. Add distance methods. Write a method distance that computes the distance between a point and another point parameter. Another point parameter means you can check the x and y of one point, and then you can measure the point with another point, let's say P and P1. So you want to know what is the distance between P and P1 in the respective of x and in the respective of y. Last section, we learn about the distance. Let me just use this distance formula, x2 minus x1, and then we do the square, plus y2 minus y1, we do the square, and we do the square root. Okay. We also need to write a method distance from origin. Distance from origin means we will get the distance between a point to the origin, which is 0.0. You can have more ideas. For example, write a method distance from the center. If the distance from the center means you will put the x and y equals to 2,2, for example, and so on. And then modify the client code to use these methods. So we will have one method to measure the distance between point and point, and the other is to measure the distance from origin, which is from a point to 0,0. Now let's see. You can have a new class. So this is the class diagram. There are 3 sections. This is the class name. The class name is point. We have 2 variables or 2 attributes, which is x and y. And let's put the value 0 as the initial value. And we have 4 methods, 1, 2, 3, and 4. Translate, location, set location, distance, and distance from origin. And then you can see there are 2 parameters on the translate, the x and the y. There are 2 parameters on the set location. Oh, this one should be new x, new y. Okay. Distance, we have other. Other means we want to get the other point, or we want to get the other object. And distance from origin. Distance from origin means a distance to 0.0. If it is 0.0, then we don't need to have any parameter. Now I just set up integer. Let me just assume that the return value is integer. Okay. So if the return value is float, you can make it as float to indicate that, okay, the data at the end is a float type. You can make integer if your data will get an integer value. But I guess this is float. This is float. Okay, so yeah, this one you can update with any data type. Now let's see with the distance method. In the distance method, we have one parameter, which is other, and you have the self parameter. So the self parameter as I mentioned to you, when you create a class, the function inside the class should have the self parameter, and self parameter. So every function should have the self parameter. And I'm going to check the distance. So I'm using dx. In this case, the delta x is the distance from the self.x, which is the current object, and the other object. The other object means, yeah, you can specify what is the object name. Then I will call the object name dot x. If I want to know the distance between P and P1, so I can call the distance, so P dot distance P1. It means I'm going to check the distance between P and P1. So P is the self, and P1 is the argument for the variable other. If I want to check the distance between P1 and P2, then I can use P1 dot distance P2. P1 is the self or the current object that we use, and P2 is the other object that we want to compare. So the x, the self.x will be the value from P1, and other.x will be the value from P2. We can do the subtraction and we get the x. For the self.y, for the other.y, we will get on the variable dy. And then we will do the formula. So you can see the formula is using the math function. We use the import and we use the math.sqrt. So yesterday we learned what the formula. Maybe we can use the dx multiplied by dx plus dy multiply by dy. We can do like this one, and we can power of 0.5. Power 0.5 means square root. Okay, so it is same. You can use the math.sqrt, or you can do the multiply with 0.5 to indicate the square root. The distance from origin. Okay, when we check the distance from origin, it means we want to see the distance of the particular object. Let's say I have P. So I call the function distance from origin. And the origin is 0, 0. Then if P dot x, let's say P1, okay, let's say P1. P1, the value of x is 5. And P1, the value of y is 2, for example. In order to calculate the distance, then we want to calculate with the original value, 0 and 0. Then we have 5 minus 0, power of 2, plus 2 minus 0, power of 2. And we do the square root. It means the value itself of x will be power of 2, and the value itself of y will be power of 2. Then we have the self.x power of 2 and self.y power of 2. At the end, we will do the square root. So we have the distance and distance from origin, and we put this one in the class diagram. So when you do with the final exam, I will give you a class diagram. And then make the Python code based on this class diagram. Okay, so you can see more exercise later how to create the Python code from this class diagram. Okay. Let's make a client code. The client code here means we want to call the class and create object. Create a new object. In this case, I'm creating P6 and call the function distance and distance from origin. Let's suppose I have P6 dot y is 4. And then I'm updating P6 dot y equals to 3. Then what is the result of P6 dot x and P6 dot y? The result is 0 and 3. Okay, because x start with 0 and there is nothing to change of x. Y originally is 0, but it changed into 4 and then it changed into 3. Then the last value is 3. When we print x and y, then we get the result 0 and 3. We want to translate the value of x and y in the P6 by 3 and 2. And x will be 3 and y will be 3 plus 2. Okay, 3 plus 2, then it will be 5. When you print x and y, the result will be 3 and 5. Now I'm going to measure the distance and I will put into one variable. I'm going to measure the distance of P6 and P1. Okay, what is P1? I think in the previous one we have P1, P1, P1. What is P1? Yeah, this one P1 is 5 and 2. Wait a moment. I need to check. Print P1.x and print P1.y. Okay. Okay. In this code, I use P1.x is 5 and P1.y is 10. So I'm using the distance and I'm using the distance from origin. And if I calculate the distance, P6 and P1, okay, this is the result. And if I'm using the distance from origin, this is the result. P6 compared to P1. Okay, P6 compared to P1. In this case, I guess the P1.x is 5. The P1.y is 10. Then we will do the distance measurement. 3. This is the x of P6 minus 5. And then we do the square plus 5. This is the x of P6 minus 10. And then we do the square. And then we do the square root. So the square root of 2 power of 2, this is 4, plus 5 power of 5, this is 25. Then this is the square root of 29. Okay. The square root of 29 is about this value, 5 point something, 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 something. For the distance from origin, it means I'm using this value, the 3 power of 2 plus 5 power of 2 and square. Then we have 9 plus 35. So we have the square root of 34. The square root of 34 is around this 5.8 something. So this is the object with class and the attributes and methods. Now we have some more improvement. When we use the object, we can use the constructor. So what does it mean by constructor? In the current state, whenever you want to create a point, the point starts with 0. X 0 and Y 0. If you want to update the point, let's say I'm using the P01 and I'm going to put the X is 3 and Y is 8. You need 3 lines. You need 1, 2, 3 to declare the X and Y of a particular location. But is it possible to make it only 1 line like this one? So you can put everything in the point class. We could rather pass the field's initial value as parameters or the attribute initial value as the parameters. We don't need to define x equal to 3, y equals to 8, but we put the 3 in the parameter. We put it in the parameter. So we are able to do this with most types of object. So when you do with integer, you can do with string, you can do with floats, and etc. Now let's take a look. When we do with the constructor, means we want to create a new method. We want to create a new method, and we are going to update the point. In this case, this point, the class point, and replace the early parts of the code using the right code. Originally, you have x0 and y0. Now, let's replace with this one. We have def. This is refers to a function. And we have underbar init, underbar. So we call this is constructor. So the constructor means init. Init means initiate. So make a new object. So what is the object? The object contains of 2 values. In this case, x and y. And the object itself in the particular name will have 2 parameters, and the 2 parameters x will be the value of self.x and y will be the value of self.y. So using this init, we call this is a special function. This is a special function for the initialization, or we call usually constructor. This is a constructor. When you construct an object or when you create an object, it will automatically put the value 3 and 8, let's say, into the x and 8 into the y. Constructor, okay, the meaning by constructor, it initializes the state of new object. So if you have a new object, you can use this init underbar, underbar init, underbar, underbar. It is to initialize. Initialize means you make one state, one new state. So it runs when the client use the underbar, underbar init, underbar, underbar. This is the special function. It does not specify a return type. This function will not have any return. Okay, the function will not have return. It implicitly returns the new object being created. Once you set up this one, it is implicit. Implicit means it is not shown directly, but it is available in the Python. And when you have the new object, that the new object will have, for example, in this case, I have X and Y. So the new object will have a new value for the X and it has a new value for the Y. If a class has no constructor, so if your class do not have any init, if there is no init in the class, Python give it a default constructor with object parameters. So what is default constructor? In some case, if there is no kind of value that you can input, let's say you have the point. It means this is the default constructor, nothing. If you have point and you have two parameters, then you need to define the value, because in the init you already define two values. Note, it requires self parameters. So still it requires the self parameter, and its attribute also needs it. Whenever you create the attribute, you need to put self. We can make the client code. Now the client code is more simple. You can make P1. Now let's suppose the P1 is a point of 2,3. So you don't need to specify P1.x equal to 2. You don't need to specify P1.y equals to 3. So you can directly put into one line. The P1 x is 2 and the P1 y is 3. Directly after you create the object, you can print the P1.x and P1.y and we get the value 2 and 3. P2. When we want to specify x is 4 and y is 3, then you can print and you can get the value. When you translate, it's also the same. When you have the x is 4 and y is 3, you can translate this one. 4 plus 3 is 7 and 3 plus 2 is 5. The remaining will be the same. Okay, so you can have the distance between P2 and P1. Okay, the distance between P2 and P1. So P2 is 7.5, P1 is 2.3. Then you can get the distance. And the distance from origin is just using the value. So it means 7 power of 2 plus 5 power of 2 and P2 the square root. The question is, what if the arguments are plain? Okay, let's see. So I'm using the object with constructor. So this is the constructor. So the constructor means something with init. Okay, this is constructor. You have underbar, underbar. init underbar underbar. I have x which is equal to xx and I have y equals to yy. So I have set location, translate, distance, distance from origin. Then I can specify the point 2, 3. Yeah, you can print p1.x, p1.y. P2 is 0.4.3. Yeah, this is x and y. P2 is 3.2. It is translated. Then you can get the new x and y. And you can measure the distance. And this is the result. Okay. Now I'm asking if it is possible to call the function point like this one. Is it possible? Originally, it is possible. Okay. When you do this one, P6 equal to point is possible. Why? Because you don't have constructor. In this case, you do not use constructor. You just use directly the variable. When you create the point, you can have the initial value of x and y, and for every object, you will have this behavior. However, after you create a constructor, the class point have their own constructor and each object should follow the constructor. If the constructor have two parameters, it means you need to also give two parameters. If the constructor have two parameters and you do not give any parameters, it errors. So what is the error? Point underbar init. So this is the constructor from the Python. And it mentioned that missing two required positional arguments, x, x, and y, y. In this case, we don't have the x, x, and y, y. Because there are no parameters, then it is error. We cannot create the object. Okay. So it will show errors and give the message that you need to define two parameters. We can define default values so that it will work when no arguments are given. How? When you learn in the functions, you can put 0. It means when you have no definition about this value, so let's put them as 0. Then x will be started with 0 and y will be started with 0. And I'm going to update the constructor. Now the constructor contains of a default value x equal to 0, y equals to 0, because there are two default value. Now I'm going to run. If I call an object, if I create an object with 2 and 3, I create another object with 4 and 3, and I create another object without parameters or without arguments. Then if you put the value 2 and 3, you can get 2 and 3. If you put the value 4 and 3, you can get the value 4 and 3. If you have no values, you will get 0 and 0 because it is a default value. Okay, that's about the constructor. Now In the object-oriented programming, we have another things to understand, which is encapsulation. What is encapsulation? Do you know capsule? It is from the word capsule. We use the encapsulation. It means we want to put everything of the point for the class. We want to put into the capsule. It means when we have the attributes or the data, when we have the methods or the behaviors, make sure that everything is inside the class and we hide hiding the implementation details of an object from its client. It means some of the data might be private. Some of the data might be in public. For example, you have your ID, Tengnook Ponhu. It should be private. But when you use the point, you can access point.x, so you can get the value of x. When you access the y, p.y, you can get the value of y. So the encapsulation, it provides abstraction. Abstraction means, you can get only the important parts of the class. What you want to share, you can get it, but some of them can be in private. So it separates the external view or the behavior from the internal view. External view, internal view. The external view means you can share to the user. You can share to the people. The internal view means only the developer or only the programmer or only the person who developed the class understands the behavior and the data. So encapsulation protects the integrity of an object's data. Now, if you pay attention on the class diagram, every of parts, I put the word, the symbol plus. Do you know what does it mean, plus? Plus, 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 and plus. It means this is public. So you can access it, you can call from the Python. So I would like to show you. Now, let's suppose I call the P1. Okay, P1 is an object. If I put the dot, what can you see? You can see a function, the function distance. You can see the function distance from origin. This is the behavior that we just created. Set location, translate. So this is the function that we created. And you can see x and y. So this is what we call as public with the sign plus. This is public. Whenever you call the object, you can get all the data. You can get all the behaviors. Now, if you change it, we want to make private attributes. So a field can be declared private. no code outside the class can access or change it. So once you set up a value to x and y, you need a special request or you need to use a special method to change the value. Now we are going to update the constructor. The original constructor is this one. We have the self x, which is the xx, and we have the self.y, which is the yy, into the new statement. We use the underbar underbar. So self dot underbar x equals to xx. Self dot underbar y equals to yy. When you do with this one, it means the data, which is the x, will be in private. So the class diagram is updated with the symbol minus. Minus. If you have minus, it means this is private. Minus means that the attributes are private. Now, let's see. Let me just delete this one. Now, let me make a new class point, and this is a constructor with the default value 0 and 0, and with private attribute. Okay. With private attribute. So underbar x underbar y. So the remaining I will not change now. Okay, so you will see later. If I'm going to access P1, okay, and I'm creating P1 with two values, 2 and 3, and I'm going to print underbar x, and I'm going to print underbar y. The result is the object has no attribute underbar x. It means that when you put the underbar, only the class understand this is a variable. But outside the class, they cannot know what does it mean by the underbar. You can do like this one. P1 dot. So you still have the x and y because it is one from the previous one. But the underbar, yeah, it is not available. So for example, here, let's say there is no issue. If I do this one, yeah, you cannot see the underbar x underbar y. You can see only the x and y because it is in public. Yeah, this error happens since you try to access private attributes. To access the attributes, you need a method specifically assessing the attribute. So you need to make method particularly to access underbar x, and you need to have a method to particularly access underbar y. You can access those two variables inside the class. So in this case, I'm using the def get x. I'm using the name get x to access the x underbar x, and I'm using the get y to get the underbar y. Oh, this is should be y. Sorry. Okay, this is only just maybe to make it better, yeah, you can see like this one. So we have the new method get x in order to get the variable underbar x, and we have another method get y in order to get underbar y. So you cannot easily access like before p1 dot x. In order to get the value, you need to access the method. You need to use the get x, the method get x in order to get the value of underbar x. You need to also call the function get y in order to get the value underbar y. Now, by giving this method, I'm using the constructor. Okay. The constructor has the default value and private attributes. I'm using a method to access the x, which is get x, and I'm using the get y to access the y. After you have a new variable, which is underbar x, which is private, so you need to update also the other section of the method. For the set location, originally you have self.x. You also need to update to underbar x. You also need to update underbar y. For the function in translate, the same. You need to update all x and y into underbar x, underbar y. You need to update this one, you need to update this one, and you need to update this one. It means only this class, only the class point understand the data of x and y. The other class or the users cannot understand if they do not create this class. If I call P1 and I have 2 points, which is 2 and 3, I can get x and I can get y by using the function get x, so I can get the value of x, and get y, I can get the value of y. And yeah, you can do again with the set location 5.6, then it means you are updating the x and you are updating the y. If I do the translate, you are updating the x and you are updating the y, and you can get a new value. Okay. This is the new class diagram. You can see the attribute. Now it is in private. It is in private. All the functions are in public. Okay. We can also make this into a private. So we will learn later about how to create this method in private. The benefit of this encapsulation it is to protect. Okay, so it provides abstraction between objects and clients. The first, yeah, it is to protects an object from unwanted access by client. For example, in order to make the bank application, yeah, you can forbid a client to change the account balance. If you have some money, of course, the user or the client cannot change. How much money do you have? Okay, so you want to change the money by yourself. It is not possible. Only the bank or yeah, only some people who have the access can change the balance. Or yeah, you can change the implementation by rewriting. Rewriting means you need to have another method, but rewriting using some other coordinate. Now you have value 3.4. But what about if the point is using radius and angle? So you can create another variable r, or another variable angle. And it allows you to constrain the object states. It means you can make some condition. If the points should have non-negative value, then you can make some kind of condition to avoid non-negative value. So that's the important things of the encapsulation. Okay, I will do the exercise next week. Today we will do the coding together. We will do the practice together, so you can know how to make the code clearly with the OOP.